Welcome to Math Science History. It's summertime. We're going to be filling this summer with posts about scientists on vacation, as well as a handful of reposts. So today's episode is going to be about Blaise Pascal. Blaise Pascal was a brilliant polymath who left an incredible legacy of mathematics. By the time you're done with today's episode, you're going to know so much more about this 17th century genius. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Birchak, is now on sale on Amazon. Buy your copy today. Before I share with you my repost about Blaise Pascal, I want to quickly point out the many areas of his brilliance that have inspired me to originally create this podcast. He laid the foundations for modern mathematics that included probability theory, fluid mechanics, and even the philosophy of science. As a young kid, he was tackling problems in geometry that would leave seasoned mathematicians scratching their heads. And at the age of 16, he wrote a treatise on projective geometry. He was truly a brilliant man who also grappled with the balance between logic and faith, doubt and uncertainty. As a result, he saw a connection between mathematics and the divine. So, as we revisit today's episode, listen with fresh ears. Whether you're here for geometry, probability, philosophy, or even history, there is something truly timeless about Blaise Pascal. So, without further ado, enjoy this repost about Blaise Pascal. Imagine it's Friday evening and you are hungry and everybody wants to order pizza. So you call your local pizzeria and hallelujah, they have a large pizza, 2 toppings for $2 deal. The restaurant offers 4 types of toppings. You want to get as many combinations of pizza with those 4 toppings because you have some hungry teenagers who are about ready to eat the moldy lasagna that's in the refrigerator. So, how many different combinations of pizzas can you create with only 2 toppings? Well, the answer lies in mathematics, of course. There's this really cool triangle known as Pascal's triangle that helps me find the answer. Imagine that we have a 1 at the top of the triangle. Below that, we have 2 ones. The reason why is because each of those numbers is the sum of the 2 numbers above it. So in this case, for the second row, the 2 numbers above it are 0 and 1. 0 plus 1 equals 1. So we're going to start making this triangle. And so below those 2 ones, in the center, we add up the 2 numbers above it. Thus, 1 plus 1 is 2. So that number below those 2 ones is a 2. But we also need to flank it with a 1 on each side because we're adding from the numbers above it, and 0 plus 1 is 1. So the triangle starts out 1, and the next row is 1 and 1. The third row is 1, 2, 1. The fourth row is 1, 3, 3, 1. The fifth row is 1, 4, 6, 4, 1. So I will post a GIF on my website at mathsciencehistory.com so that you can get a visual of how to build Pascal's triangle. So, for the exercise about the pizzas, the answer is 6. And this is how we got it. We counted down 4 rows starting at the second row. Then, not counting that first value of 1, we count over 2 numbers. The value that we land on is number 6. We can order 6 different combinations of 2 topping pizzas, which in my opinion is not enough for hungry teenagers. But that's not our story. Our story is about Pascal. And in mathematical terms, Pascal's triangle is a triangular pattern of binomial binomial coefficients. It is the coolest triangle ever because this triangle allows us to solve combinatorial problems, statistical problems, find Fibonacci numbers, solve compound interest, and so much more. In my opinion, it is one of the most useful tools in mathematics. The triangle got the name from the mathematician Blaise Pascal, who wrote the treatise on arithmetical triangle in 1654. Though the triangle had been around long before he wrote it, his name put this really cool triangle on the map of mathematics. And in the treatise that he wrote, he presented a tabular presentation of binomial coefficients created out of columns and rows. And I'll also show this on my website at mathsciencehistory.com. We'll be right back after a quick word from my advertisers. Pascal was born in Clermont-Ferrand, France, on June 19, 1623. Pascal's mother died when he was only 3 years old. His father raised him and his two sisters. They eventually moved to Paris in 1631, and throughout his entire life, Pascal suffered from poor health. Regardless, this did not stop him from continually applying his intellect. He was considered a prodigy. His father, Etienne, was a tax collector, a counselor to the French king, and a civil servant. Etienne chose to homeschool him and his sisters because he didn't trust the rigor of the educational system in France. Even though his father was a mathematician, he discouraged his son from learning math at a young age. His father knew how fulfilling math was, and he felt that Pascal could immerse himself in the joy of math when he was older, but first he wanted to teach him humanities, philosophy, literature, and the other classical studies. Nevertheless, despite his father's resistance to introducing him to math, Pascal decided to learn math on his own. The story actually reminds me of the story of Agatha Christie, whose mother did not want to teach her how to read until she was at least 8. Agatha pretty much did her own thing and learned how to read by the time she was 5. Sometimes you just can't stop brilliance. By the time Pascal was 12 years old, his father would take him along to weekly visits with the Society of Mathematicians at Académie Libre. Here they would discuss current topics in science and mathematics. At these meetings, Pascal had the opportunity to meet well-known mathematicians, including Marin Mersenne, Gerard Desargues, Pierre de Fermat, and René Descartes. Pascal was so inspired and motivated that by the time he was 16, he had published his first essay on conics. Pascal was truly ahead of his time. When he was 16 years old, he designed and created a calculating machine. For 3 years, he designed 50 prototypes, and he finished 20 machines that he called Pascal calculators. When he was 23, he became fascinated with physics. A family friend introduced Pascal to Torricelli's experiment, which involved a tube full of mercury immersed in a bowl full of mercury. What the experiment showed was that when the tube was placed in a bowl full of mercury, the mercury would fall in the tube to 760 millimeters. No more or no less. Even when the tube was moved, shaken, or tilted, it always remained at 760 millimeters. This was due to the influence of atmospheric pressure. Pascal was fascinated with this experiment, and as a result, even though he continued to struggle with his poor health, he immersed himself in physics. Thus, by 1651, Pascal wrote a treatise on the vacuum, as it referred to the Torricelli experiment. Sadly, this was also the same year that Pascal's father died. By 1654, Pascal published his treatise on the arithmetical triangle. Meanwhile, he continued to struggle with poor health, as well as contend with religious beliefs. In 1654, he fully committed himself to God. As a result, from that point forward, most of his writings were philosophical. He wrote a work called The Provincial Letters, which were a series of pastoral letters. He also started to compile a collection of writings that were posthumously titled Pensées, which in French means thoughts. Pensées was considered a preparation of Christian apologetics. It was a collection of about 1,000 fragments of his writings that were based on his beliefs about miracles and God's proof of existence. In Pensées, Pascal wrote, quote, "All of humanity's problems stem from man's inability to sit quietly in a room alone," unquote. That is something we can all learn from, especially in these days. Just the other day, actually, I was telling my husband that if I had a time machine, I'd travel to the 1990s, before the internet took over every household, before smartphones ruled our lives, and before electronic interruptions became commonplace. We could grab a book,
sit all day without one interruption and immerse ourselves in that one book. Pascal also wrote, quote, "Man's greatness lies in his power of thought," unquote. Pascal understood the value of thinking and mastered the art of deep contemplation in every subject, from math to physics to God. On August 19th, 1662, Pascal died from a malignant stomach tumor. He was only 39 years old. However, because of his ability to immerse himself in his academic studies, in his brief life, Pascal left a profound intellectual imprint on the fields of math, physics, and philosophy.
Thank you for tuning in to Math Science History. If you enjoyed today's episode, please leave a quick rating and review. They really help the podcast. You can find our transcripts at mathsciencehistory.com. And while you're there, remember to click on that coffee button, because every dollar you donate supports a portion of our production costs and keeps our educational website free. Again, thank you for tuning in. And until next time, carpe diem.